Good morning, everyone. Good morning.
Good morning, sir.
Yeah, yesterday we were looking at finding a GCD of given two numbers, and we have seen one method, which is Euclid's algorithm. We have represented it in two ways. One is stepwise explanation of the description of the algorithm. The second one is an algorithm wherein we have specified how does it work, right? So just as with many other problems, there are several algorithms for computing the greatest common divisor as well. So by definition of the greatest common divisor, we know that the greatest common divisor of m and n as the largest integer that divides both numbers evenly. We know that. Obviously, such a common divisor cannot be greater than the smaller of these numbers. So what we are trying to do here is in the next algorithm, that is our consecutive integer checking algorithm, we are trying to take minimum out of given two numbers. If the greatest common divisor if we wanted to find out, then we find out GCD of for example, you wanted to find out a GCD of 8 and 12, then we will say T is equal to minimum of 8 and 12. So we will take a minimum of these numbers. As we know, a common divisor cannot be greater than the smaller of these two numbers. So we denote that smaller number by T. And according to the algorithm, so in step 1, we will assign the value of min of m and n to T. In step 2, we will divide the first number by T. If the remainder is 0, we will go to step 3. In step 3, we will take the second number and we will divide it by T, the smaller number in this pair. If the remainder is 0, then we will return T as a GCD of these two numbers and we will stop the algorithm. In either of step 2 or step 3, if the remainder is not 0, then we will go to step 4. Right? So either of we'll check the step 2, we will check the step 3. If either of them does not give results as 0, then we will go to step 4. In step 4, what we are going to do is decrease T by 1 and we will loop back to step 2. Right? That's what we are going to do. So let us take an example, the same example which I have shown here, and we will work out this algorithm. So let us start. Suppose I wanted to find GCD of 8 and 12. So in the first step, what we are trying to do is we are saying T is equal to min of 8 and 12. So we will assign T with 8. So next we are going to go to second and we will take 8 divided by T and we will find the remainder, which is 0. Right? So once we do this, we will go to step 3. We will take a look at here. So divide m by t. If remainder is 0, we are going to step 3. So in step 3, what we are going to do? We are dividing n by t. So we are dividing n by t. So n is 12. That's the third step. So what we are trying to do is we are going to find out, divide it by 8 and find the remainder, which is equal to 4. Right? Now, as you can see in step 3, after we divide n by t, the remainder is not 0. We have got 4. So if remainder is 0, we can return it as a GCD. Otherwise, we will go to step 4. What does we do in step 4? We will decrease t by 1. At step 4, you decrease t by 1. And t becomes equal to 8 minus 1, which is equal to 7. Now, once you do this, step decrease by t by 1, and you will loop back to step 2. In step 2, you are dividing m by new value of t. Right? So, you are going to step 2 again. Right? You are going to step 2. You are going to divide 8 by 7 and you are going to find the modulus of this operator, which is 1. So when you do this, divide m by t. If remainder is 0, we will go to step 3. Otherwise, we will go to step 4. Step 4 is again decreasing t by 1. Okay, step 4 is again decreasing t by 1. So 7 minus 1, which is 6. So again, you are going to go to step 2. You will do 8 modulus 6. Remainder is not 0. So you will go to step 4. You will decrease t from 6 to 5. You will repeat this step. Then you 8 modulus 5. The remainder is 3. So go to step 4. You will make it as 4. Right? Now you will again go to step 2. And you will divide 8 by 4 and the remainder is 0. In step 2, remainder becomes equal to 0. Right? If the remainder is 0, we will go to step 3 and divide n by t. So you will take the second number, which happens to be 12. Right? You go to step 3, you take 12 modulus 4, which is also equal to 0. If step 3 is also 0, if the remainder is 0, then what you are going to do? You are returning t and star and you will return 4 as a GCD of these two numbers. Right? So this is the second algorithm to find the GCD of two numbers. But you can see that unlike in our Euclid's algorithm, this algorithm which is presented here does not work correctly when one of its inputs is 0. But you can check in Euclid's algorithm, even if you give one of the input is 0, it was working. But in this case, it does not work. So one of the properties of algorithm, so it's very important for us to specify the range of algorithms, the boundaries of input explicitly and carefully. So that's what is required. How can you check the Euclid's algorithm is correct or not? We would have seen there that the second number is decreasing every time in every loop, right? Once it becomes 0, it does not become negative. So that is how we have checked the algorithm. Here, if you take minimum number and you decrement, right? You divide it by 0, it does not work here. So the range of inputs for any algorithm needs to be specified carefully. So this is second algorithm. There is one more algorithm which you could use for finding the GCD of two numbers. That is a middle school procedure by prime factorization method. As you can see here, the middle school procedure says in step 1, you will find the prime factorization of m. In step 2, you will find the prime factorization of n. And in step 3, you will find all the common prime factors. And in step 4, you will compute the product of all the common prime factors and return it as a GCD of two numbers. So procedure looks little complex than the Euclid's algorithm. Let us try to write solve a problem with this procedure. So we will find, given m and n, we'll find the prime factorization of m, then we'll find the prime factorization of n, then we will find the common prime factors, and we'll compute the product, which will be the GCD of given two numbers. Let us take an example, the one which we have taken in Euclid's algorithm, that is m is equal to 60 and n is equal to 24. Can you tell me the steps to find the prime factorization of these things? Step 1, what are the prime factorization of m? Prime factors of m?
So 2, 3.
Then
5.
2, 3, 5, right? So that is 60. So 2, 3 and 5. Then step 2, the prime factors of 24.
So 2, 3.
Okay.
Um,
So this is 2, 2, then 3, right? So now what are the common factors here?
2 and 3.
Then you are going to have 3. So you'll get 12 as GCD. Okay, this is the one more method of finding the GCD of two numbers. This procedure does not even qualify in the form presented as a legitimate algorithm. Why? Because the prime factorization steps here are not defined unambiguously. We require a list of prime numbers, so we need to generate the prime numbers. In the step 3 is also not defined clearly enough. Its ambiguity is much easier to rectify than that of the factorization step. That is, we need to give a detailed algorithm in step 3 to specify how would you find common elements in two sorted list. So given two prime factors of n and n, it says if you sort that list, you need to specify a clear steps or all steps in an algorithm in step 3 to indicate how you are going to find the common elements in these two sorted lists. Even in the other two steps, you need to generate the prime numbers. So one such method could be of this sort, and you need to specify generating this prime numbers is also an algorithm. The one method is to list all the numbers like 2, 3, 4, 5. Till 25. Then you are just deleting the multiples of 2, right? Then you will take the next number and you go on deleting the multiples of this as well. So you continue this process to generate the prime numbers. And the step 1 and 2, the generation of these prime numbers, you need to specify it as an algorithm. So then it becomes more clearer what are these steps are in this algorithm. So as you can see, the algorithm which we have discussed, the procedure is more complex than and it is slower than the Euclid's algorithm. So this example was taken to discuss the important points about the algorithm actually. What does it say? There should not be any ambiguity. So the no ambiguity requirement for each step of an algorithm cannot be compromised. As we have seen in the consecutive integer checking algorithm, if one of the input is 0, it does not work. So it's very important that the range of the input for which an algorithm works has to be specified carefully. The same algorithm can be implemented in different way, and there may exist several algorithms for solving the same problem. So that we have seen. The algorithm for the same problem can be based on very different ideas and can solve the problem with dramatically different speeds. So now you need to, given a problem, you need to find the algorithm which is the efficient one. So that's the whole idea of this course is all about. And the next topic of discussion is algorithm design and analysis process. So first step when you are trying to develop an algorithm, first step is to understand the problem. If you one minute. Next topic which we are going to discuss is algorithm design and analysis process. Process involved in developing an algorithm. First, you need to understand the problem. You need to read the problem description carefully, and you may have to ask question if you have some doubts regarding the problem. First, you should know what is the input to the problem and what are all the outputs it's going to generate. Once you read the problem statement thoroughly, carefully, and you need to, if you have doubts about the problem, you need to ask once again. If there is a customer who has given you the problem, you are going to ask him the doubts and you get the clarification and you refine the problem statement, and you will take some few examples and you work with this problem to see for that particular input it generates the output or not, and what kind of inputs are given, and you need to do some few example by hand, and you need to think of some special cases for the same and ask questions if it is required again. And you should make sure before you write an algorithm you understand the problem statement properly. Once you understand the problem statement properly, then there are certain other steps you need to do. You need to see the computational means. You need to ascertain the capabilities of computing device for which you are writing an algorithm. So when you are writing an algorithm, the capability of the computer system for which the algorithm is intended has to be seen. So you will be deciding on asserting the capabilities of computing device. So we consider there are two architectures. One is a Van Neumann architecture. This is based on the idea of random access machine. In random access machine, the assumption is that the instructions are executed one after the other. So such architecture in which algorithms are designed to be executed on such machines are called sequential algorithm. So there are newer computers which executes these instructions concurrently. Such algorithms are called parallel algorithms, and there are system which runs these instructions in parallel. But most of the time when we design an algorithm, the RAM model is preferable. Now the second thing is, should we worry about the speed and amount of memory of computer at our disposal? Not really. The computer scientists prefer the study of algorithms independent of specification parameter for a particular computer. So when we would like to compare different algorithms before even we code, then we are going to do a theoretical analysis where we will do the analysis without using any computer or writing this algorithm into the code and executing it onto the computer. So that's the thing which you are going to look into. That is, you are asserting the capabilities of the computer device. Then you have to decide what kind of algorithm. We need to choose between exact versus approximate problem solving. So why would we opt for an approximate algorithm? First, there are some important algorithms like traveling says per problems that simply cannot be solved exactly for most of their instances. Secondly, these available algorithms for solving problem exactly can be unacceptably slow because of the problem intrinsic complexity. So in the case of exact algorithm, for all legitimate input, it's going to give the correct output. In approximate algorithm, it is nearly correct. You are going to find given certain instances of input into the approximate algorithm, and you can find the you can see the output and you can see the error which is there in the output. If the error is above certain threshold limit, it is acceptable. Otherwise, these algorithms which are which cannot be solved in finite amount of time, there are no such algorithm exists as well. So then we are going to decide about approximate algorithms which we are going to use and solve the problem. Then we also have to decide appropriate data structure, because that the use of a proper data structures plays an important role in the performance of the algorithm execution. So you have seen linear data structure like stack, queue, nonlinear data structure, trees and graphs. So whenever you are writing an algorithm, if you change the data structure, it may impact the performance of an algorithm. It may improve the performance of algorithm. You are going to see some of the examples in this subject, wherein you will see by changing the certain data structure, the same algorithm can work efficiently. So deciding on appropriate data structure is also an important component which you need to decide on. Then you need to design the algorithm. So an algorithm design, there are various algorithm design techniques which will be discussed, like divide and conquer, transform and conquer, greedy technique, or dynamic programming. You are going to see the problem, and if it fits into any of this design technique, you are going to choose this design technique and you are going to write an algorithm. So how do we design an algorithm to solve the given problem? This course teaches you several general designing techniques which I have indicated now, and majority of our units from second unit onwards are devoted to individual design techniques. So you will, after going through this course, given a problem, give me a minute. So the majority of the course teaches you all kinds of design techniques from unit 2 to unit 4, and you are going to use one of these techniques or combination of these techniques to generate a new algorithm for the new set of problems which you'll encounter in the real world scenarios, right? So you're going to use a algorithm design technique. Once you design the algorithm, you need to specify this algorithm. There are different ways in you can specify the algorithm. You can specify the algorithm using natural language, but it is kind of ambiguous in nature. So we can go for pseudocode, which is a mixture of natural language and programming language like construct. A pseudocode usually is more precise than a natural language. So for the sake of simplicity, we omit declaration of variables in our pseudocode and use indentation to show the scope of such statements inside for, if, and while loop. So these are all the kind of programming constructs which we are going to use in the pseudocode. There is one more method of representing an algorithm is a flowchart. Is a method of expressing an algorithm by collection of connected geometric shapes containing description of the algorithm step. So you could specify your algorithm either of these three methods. So once you specify that method, right? So the first step is to understand the problem. The second step is to ascertain the capabilities of the computational device. Then you will choose whether you want to go for an exact algorithm or an approximate algorithm based on the problem. If problem cannot be solved using an exact method, then you are going to use the approximate method. Then also you will just check the data structure which is suitable, and you will also check by changing the data structure whether there is an improvement in the is there an improvement in the performance of the algorithm. So then you use certain algorithm design technique and you will design the algorithm. So once you design the algorithm, you prove its correctness. You take some examples by hand and you just give some instances of input and see it produces a legitimate output or not in a specified amount of time, right? So if it is correct, then you proceed to analyze the algorithm. If that is not correct, if you see for any of these inputs, the different cases of inputs which you are giving, if it is not giving proper output for certain cases, then it indicates that the algorithm is not correct. Then what you are trying to do is you wanted to come back and do this process again, right? So you may have to change the design technique, then come up with a newer algorithm, prove its correctness. If it is not correct, change the algorithm design technique or use the certain other data structure. So unless you prove it correct, you are not going further. Once you prove correct, you go and you do the analysis of an algorithm in the next step. So you will analyze the algorithm in terms of space and time. You are going to see how much time you are going to take for executing the algorithm. In the sense how much time the algorithm is going to take. Then also in terms of memory, how much extra memory it's going to take. This is called as time efficiency and the space efficiency, which will be looked into. When you are doing the time efficiency and space efficiency of the algorithm, you can do either in the theoretical way or in the practical way. In the theoretical way, you don't code it, you just use the algorithm statements, and theoretically by induction, theoretically you are going to see how efficient your algorithm is. Once you know the from the set of algorithms which you have developed, and you are going to choose the one among them as which is efficient, and then you go for coding. This is the detailed process of algorithm design and analysis problem. First you take the problem, then use a design techniques to design the algorithm, then you check the correctness. In the mathematical way, you induction to prove the correctness as well. Then you will analyze the algorithm for the performance both in time and space. Once you have confirmed that it's an efficient algorithm from the pool of available algorithms which you have developed, then you are going to code the algorithm. So this is regarding the algorithm design and analysis process which you are going to do for every algorithm in this course. The next one is the next discussions which we are going to do is important problem types which we are going to discuss. Okay, so this slide is developed by one of my colleague Vandana, and there are different important problems which we will discuss one by one. So important problem types are sorting problems, searching, string processing, graph problems, combinatorial problems, geometric problems, and numeric problems. These are all the different kind of problems we are going to discuss. And also we may discuss certain problems specified here under different design techniques. So we will discuss some of the sorting technique is divide and conquer, transform and conquer. So we will be discussing the same problem under different design techniques. So the first problem type is sorting. What is sorting? Given a list of unordered elements, you should reorder it in either in ascending or descending order. So why do we do sorting? It helps in searching. For example, if you wanted to sort the student records according to their USN, the USN becomes the key here. Using the key value, we are going to sort the records. Or if a company wants to sort the records of their employees, so employee ID becomes the key, and using the key, we are going to sort the records so that if you are searching an employee or searching a student, then it becomes very easier. So we go for a sorting algorithms. So we use a word called key for the key in the record. So there are many techniques which are available for sorting, like selection sort, bubble sort. Selection sort and bubble sort comes under brute force technique in unit 2. Then insertion sort is decrease and conquer technique, wherein merge sort is divide and conquer. Heap sort comes under a technique called transform and conquer. So we need to evaluate the sorting algorithm complexity by the most basic operation which you do in sorting is the key comparison. Then once you sort, you also should see the properties like stability of a algorithm and in place property. A stability of a sorting algorithm is called stable if it preserves the relative order of the two equal elements in the given input. In place algorithm is one which does not use extra memory while sorting. So the next one is the problems of site searching. So you would have seen, searching is to search a key in a given set of element. For example, if you have a bank records and the key is your account ID and you wanted to search the account number for processing, then you need to do a search in this record using this key, search key. So there are several algorithms which are available for search key, like a brute force method called sequential searching and binary searching. You would have seen binary search tree, which uses the concept of binary search. We have certain string processing algorithm. A string is a sequence of character from the alphabet, and most of the computer scientists are interested in finding the pattern string in a given text. So they wanted to search for a pattern string. You could think of applications in clustering. If you wanted to cluster a document of different kinds, that is the documents belonging to science, documents belonging to art, documents belonging to finance. So you have certain keywords which are there in these documents, and you need to search for those keywords. And you also are going to see the frequency of keywords which is available in this particular documents, and based on that you are going to apply mining to cluster similar documents into one group, right? Each group you are going to put similar documents into each group. Then it's very important for us to find the pattern, right? If I say data mining, which is the document which I am looking for, then I need to search these keywords in a document, and you need to come up, you need to match the string. You need to come up with the algorithms for string matching algorithms for all these things. So there are several algorithms which we are going to discuss in this course. Right, so we are going to see a brute force algorithm and Boyer-Moore algorithm, and there are Haskell's algorithm. There are different algorithms which we are going to discuss in this course. Such problems are called as string processing problems. Then there are the problem types like graph problems, like the real world problems can be modeled as graph, whether it could be air or road network or communication network or modeling World Wide Web or project scheduling. So these real world problem could be represented as graphs. There are certain algorithms like graph traversal algorithms. You have seen in your data structure course, two of them, depth first search and breadth first search algorithm. To visit every node in a graph, you use graph traversal algorithms. Then there are certain shortest path algorithm to find the shortest path between given source and destination. It could be in the network to transfer the packets from a designated source to the destination, or it could be in a road map wherein you wanted to find the shortest path to travel from one city to other city. So if you model all this as a graph, you need to come up with an algorithm to find the shortest path and to traverse and visit every node in a graph. Then the other thing is topological sorting. If there is a dependency for a task on the other task, then you are going to use the topological sorting. This could be used in many application areas. For simple example, if a student has to take a course to complete his degree, and the prerequisites are mentioned, and it is mentioned are represented or modeled as a graph. If there is course C1 and C2, which could be taken independently, they do not have any prerequisites. Then C3, course C3, to complete course C3, student should finish the course C1 and C2. As you can see, I am representing that the task of taking up the course C3 depends on completing the task C1 and C2. You need to complete prerequisite C1 and C2. And there is a course C4. To complete C4, you would have completed C3, and the other course, the student has to take 5 course. To complete the course 5, you would have completed C3 and C4. Now you need to write an algorithm called topological sorting algorithm. You are going to discuss this topological sorting in one of the chapter. The topological sorting can be done using DFS method. So using the DFS traversal technique, we are going to do the topological sorting to say in which order a student can take a course. He can take a course in the order C1, C2, then he should take C3, then he should take C4, then he should take C5. So given the courses and these prerequisites, and if that is modeled as a graph, we should come up with an algorithm to specify the order in which the student needs to take the course. So such problems comes under the category graph problems, right? So several such algorithms you are going to discuss. The next type of problem is combinatorial problems, like finding the shortest path in a graph, right? So the remaining type of problems, we will discuss it in the next class. There is combinatorial problems, and then we have geometric problems, finally we have numeric problems. So we will discuss these things in the next class. Thank you.